Right, 8th grade math, we're on 2.6, which is on, find the page, page 83 in your book. We have some number properties that we're going to talk about. Oop, that line does some you know means addition. Product means to multiply. And these three properties are I guess we've talked about them. We haven't really seen these properties right here are talked about in some different, I think we probably talked about them before. The identity property of addition means when you add 0 to a number, like 1 plus 0 equals 1, 2 plus 0 equals 2. The identity property is 0. When you add 0 to a number, you get that same number. The inverse property of addition is when you, and I'm looking in your book, if you look where the definitions are, it's back on on page 63, actually page 64. So the inverse property is when you add a number and its opposite, like 5 plus negative 5, you get 0. Inverse is another way to say opposite. And the identity property of multiplication, to get the same answer, 1 times 1 is 1, 1 times 2 is 2. So the identity for multiplication is 1. The identity for addition is 0. So let's take a look at some of these using the commutative property. The commutative property is the first thing in the key concept box. So you guys can stop this right now and write the key concept in words. And basically, commutative property, it's for addition and multiplication. And it basically just says you can switch the order of the numbers and still come up with the same answer. There is not a commutative property for subtraction or division. So take some time here and write those down, and then I'll erase, you turn it off, write down the key concept box, and then come back with me and we'll do example 1. So example 1 says, tour biking, you are going on a 400-mile bike trip. You plan to cycle at an average speed of 12 miles per hour for 7 hours a day. Can you complete the trip in 5 days? Well, you're basically seeing, can you go 400 miles if you go 12 miles per hour for 7 hours a day, and you're going to do that exact thing for 5 days. So you're basically multiplying 12 times 7 times 5. So as far as the commutative property, that means you can multiply these numbers in any order, whichever makes it easier. And you know, 12 is a pretty big number. I know 12 times 5 is 60. And then it's easy to multiply 60 times 7 because 7 times 6 is 42, excuse me, and you add a 0, 420. Or you could take 12 times 7, but you know, that's I don't know my 12's that fast, I could figure it out. But if you can combine numbers to make it easier, that's what the commutative property can do for you. And that would be miles. And the question was, could you go the 400-mile bike trip in those 5 days at that speed? And the answer would be yes, you can. So there's that. They're talking about, looks like they did it the same way I did it. Okay, the unit for the result is miles, which means the label. And they're showing you how to get the label. I knew that was distance, so we knew it was 420 miles. All right, so using the commutative property right here, one of the first things that I do is remember when we talked about subtracting integers, when we're dealing with integers, let's get rid of any subtraction. So this would be a situation where we would boom, boom. So we're going to change it, adding the opposite. And then now, let's add. And I always add negatives to negatives, and that's the commutative property. It doesn't matter what order you add in. So negative 54 plus negative 16 is negative 70 plus 35. So remember, when the signs are opposite when we're adding, you subtract. So 70 minus 35 is 35. There are more negatives than positives, so the answer is negative 35. And there's it talks about changing it, going through, adding the negatives with the negatives, positives with the positives. So the guided practice says, suppose in example 1 you only bike for 6 hours a day at an average speed of 14 miles per hour. Can you complete the trip in 6 days? So let's take those numbers and multiply them. 14 times 6 times 6, and we're still going those 400 miles. So, I don't know, I guess I would take 6 times 6 and get 36. Then times it by times 14. I don't know if there's really any easier way to do that besides using a calculator, right? You could go 504 miles then, and yes, you would be able to finish that trip, unless I multiplied wrong. Let's see what they do. And they didn't. They just, it doesn't matter the order. So yes, the result is miles, and yes, well, you really make it then. Use the commutative property to evaluate the expression. So I see right away that I think of this as quarters, and 4 quarters make $1, so that makes 100 times -9 is -900. And boy, that made it a lot easier instead of doing 4 times 9 and get the answer and then that. So look for shortcuts. So they did the same thing. Got that answer. Okay, so I'm going to change, remember we're supposed to change all the subtractions, so I'm adding the opposite, boom, boom. -13 and -7 make -20 plus 34, and we subtract and end up with 14 positives. If you're not sure how I'm getting that, please ask. Use the commutative property to evaluate the expression. So you'll notice, just because these brackets are here, since it's addition, it does not matter the order. So let's add the two fractions together. They already have common denominators. So you add the tops and you get 7/7, and 7/7 is equal to 1. So you end up with just 1 plus 8, which is 9. And you could really be stuck on that problem for a long time with those fractions, but look how much easier that is when we see it's all addition and we can change the order of adding them, even though there was brackets around them. In addition, it doesn't matter. Got the right answer. So same thing here. We'll take those fifths, 3/5 and 2/5, and get 5/5, which is equal to 1, and 1 plus 3 is 4. And they're doing the same thing, showing it out. There's our work. Okay, example 4, using the associative property. And there's another key concept box, so guess what? Turn off the video and write this key concept box on page 84. Okay, associative property basically means that you can move the parentheses around and multiply in any order you want to. Right here, what I would do on this problem right here, I mean it's different for sometimes for every problem that we do. And actually in example 3 we were moving them too. That's exactly that associative property, we were moving those around. So, I like 10, so I would probably do 5 times 2 first. I would write those first and multiply those. And 5 times 2 is 10, times 11 is 110. There we go. I wouldn't even worry about symbols. Use properties to evaluate the expression. Well, they're all additions, so I can take 12 plus 18, which would be the associative property, and 12 plus 18 is 30, plus -34 would be -4. And I believe I used the commutative property. I moved them around. And then the associative property because I added them. I'm not as concerned. I just want you to be able to realize you can switch them around, you can add in any order, you can multiply in any order. That's basically the main thing that we need to get there. Same thing here. Use the associative property, regroup these. Go 4/5 plus 1/5 plus 8. And we know that's 5/5, which is 1, and 1 plus 8 is 9. That looks familiar. Did we do one like, I think that was kind of like the one we did in the example. Use properties to evaluate. Well, I'm going to switch these around and take 12 times 1/12. That's the multiplicative inverse, because those are going to equal 1. And then all you have left is the 6. 1 times 6 is 6. There's the commutative property. They changed the 12 times 1/12. And I don't know if we've talked about the multiplicative inverse. I'm sorry if we haven't, but anytime you take a number 12 times its reciprocal, when you flip it over like a fraction, that always equals 1. So this one I would take 5/6 times 6/5 times 3. I would do these first. And if you multiply, you get 30 over 30, top times top, bottom times bottom, which is 1. But you can also cancel. Remember, in the diagonals, everything cancels out, leaving 1. It doesn't go to 0, it leaves 1. So the answer there would be 3. No, that's a lot faster than multiplying those in that order. And they're doing the exact same thing. Okay, so it's very important. You kind of show some stuff right. This one, notice I'm regrouping them. 4 times 1/4 times 23, and I notice if I put 4 over 1 and I group those together, there's a number and its inverse. It's supposed to be a times. So that'd be 4 over 4, which is 1, and 1 times 23 is 23. And I've written on that one, you can't see it. Again, 50 and 4 are easy to multiply. It's like 4 $50 bills would be $200, and it would be negative 200 times 46. And I would just do 46 times 2 is 9, that's a 2, 92 with 2 zeros added on. So negative 9,200. Where'd I go wrong? 46 times 2, 8, 9. Is that right? Oh, they have it wrong. In the book, I'm looking at the example in the book, that's supposed to be a 2. They put that in wrong. So that would only be 100, which would make that then be 4,600. Oh, I was like, wow, how did I mess that up? Wait a minute, let me get off of this. Oh, shoot, anything times 0 is 0. So it doesn't matter what's inside there. When we multiply it times 0, the answer is 0. That one's easy. Again, I've written all over everything. Again, I'm going to group this 10 with this 1 times negative 6, and 10 over 10, those are going to be equal 1, negative 6. So look for those shortcuts to regroup things, and make sure you're showing your work. Make sure you write these problems out. I know sometimes we're tempted to not show our work very well, but I'm looking for work on your assignments. So we'll see you next time.